Alright, in this video we're going to be looking at the addition rule in probability. And we'll look at the intuitive addition rule and the formal addition rule. We'll talk about disjoint or mutually exclusive events. And then we'll talk about complementary events that are related to the addition rule. Okay, so let's start off with some definitions here, or a definition. We'll start off with a compound event. Now, usually compound, or in compound words, it usually has the word "and" in it. Okay, so a compound event is going to be this. Any event that contains or containing two or more simple events. Okay. Any event that contains two or more simple events is considered to be a compound event. Okay, now for the addition rule, its notation is going to be this: the probability of event A or the probability of event B. Okay, now what this means is this: you have the probability that A occurs or event B occurs, or both A and B occurs. Okay. Now in this case we're using what they call the inclusive OR. And the inclusive OR means this: A or B or both. Okay. So now when we find the probability of that event A occurs or event B occurring, we find the total number of ways that A can occur and the total number of ways that B can occur, but we find that total in such a way that no outcome is counted more than once. Okay, so here I'm just reading this very important rule here when you're finding the probability of event A or event B occurring. Because here you want to find the total number in a way such that no outcome is counted more than twice, more than once. Okay, so in this case here, here's what the formal addition rule states. And we'll be using this to solve problems. If you have the probability of event A or B, that means you have the probability of event A plus the probability of event B, and then you have to subtract off the probability of event A and B occurring. Okay, so that's the formal addition rule. Okay, and later on we'll look at some examples of how to apply that formal addition rule to probability type problems. Alright, now I do need to introduce another definition. And that definition is going to be disjoint. Okay, which can also mean mutually exclusive. Anything that's disjoint means this: events A and B cannot occur at the same time. Okay. And I'll give you an example of a disjoint event. Let's say we have a deck of 52 cards. One event would be selecting a black card then the second event will be selecting a red card. That's an illustration of a disjoint event, because you cannot select a black card and a red card at the same time. Okay? So in this case here, that will be disjoint. And we'll look at some examples of what disjoint events are. Okay, so in this case here, let's look at this first example. Here we want to decide whether the following two events are disjoint. Number one is electing a President of the United States, and then number two, electing a female candidate. Well, the female candidate could be a candidate for President of the United States, so that those two events can happen. So here, these two events would not be disjoint, because it is possible to elect a President of the United States and then elect a female candidate. Alright, example 2. Determine whether the two events are disjoint for a single trial, where you have randomly selecting a statistics student and getting someone who brings a pen to class, and then randomly selecting a statistics student and getting someone who brings a textbook to class. Those are not disjoint, because it is possible to select a statistics student who brings a pen to class and brings a textbook to class as well. So here, this is also not disjoint. And then the next example, randomly selecting someone who plays soccer, randomly selecting someone who takes a history course. Well, someone who plays soccer can also take a history course as well. So those two are not disjoint. Okay. So these are just examples of events that can be disjoint or not disjoint, meaning that both events A and B cannot happen at the same time. Okay. Alright, the next thing I want to talk about is the complementary rules, well, complementary events, and the addition rule. Now, in one of the videos I did talk about what complementary events are. If you have a bar, that means that event A does not occur. Okay. So here's some of the rules for the complementary events. If you have the probability of event A, and then you add to it the probability of a complement, that's going to be equal to 1. Okay? Because these two are opposites of each other, so the sum of those two opposites have to be equal to 1. And then the probability of a complement would be equal to 1 minus the probability of event A occurring, and then the probability of event A will simply be 1 minus the probability of a complement. Okay, and an illustration of that would be this. Let's say we had this right here. Let's say that this circle right here represents the probability of event A. Then what's on the outside of this represents 1 minus the probability of event A. And that's going to be the probability of A complement. So you can pretty much see that the probability of event A and the probability of A complement, if you add those together, it's going to equal to 1. Okay. Now let's look at some examples that follow the formal addition rule that I just got through talking about, or just introduced. Okay, so, well, before that, let's look at this example that deals with the complement. A research center poll showed that 79% of people believe that it is morally wrong to not report all income on tax returns. What is the probability that someone does not have this belief? Well, the probability of not having this belief will be will be 1 minus the probability that someone does have the belief that it's morally wrong to not report all income on tax returns. So this will be 1 minus 79% as a decimal will be 0.79. So 1 minus 0.79 will be 0.21. So here the probability that someone does not have the belief that it is morally wrong to not report all income on tax returns will be 0.21. Okay. Alright, now let's look at some examples that deal with the formal addition rule. Alright, in this case here, this first one is this. Alright, the following data summarizes results from 1,000 pre-employment drug screening tests. If one of the test subjects is randomly selected, find the probability that the subject had a positive test result or a negative test result. Alright, so in this case here, we want to find the probability of someone with a positive test or a negative test. Now, here we got the positive test column here and the negative test column here. These two are mutually exclusive because it's impossible for you to have a positive and a negative test result. Okay, and before I work this out, let me put the total columns here and rows. 81 and 81, that's 162. 7 and 831 is 838. And then 81 plus 7 will be 88. And then 81 plus 831 will be 912. And that total should be 1,000. Okay. So, since these two have nothing in common, we can easily find that probability. It'd just be the probability of getting a positive test result plus the probability of getting a negative test result. So for a positive test result, it's going to be the sum of this column right here. 81 and 81 was 162. So it's 162 over 1,000 plus the probability of getting a negative test result. Add 7 and 831 together, you're going to get the 838 out of 1,000. Now add 162 and 838, you're going to get 1,000 over 1,000, which is simply going to be 1. So here, the probability of randomly selecting a subject that had a positive test result or a negative test result is 1. So in this case, it is certain that a randomly selected individual will either have a positive test result or a negative test result. This is an example of a certain event where the probability is 1. Okay, here's another example. The following summarizes results from 982 deaths that were caused by accidents. If one of the pedestrian deaths is randomly selected, find the probability that the pedestrian was intoxicated or the driver was intoxicated. Okay, so here let's put our total numbers in. So if I add 91 and 225, that'll be 316. Add 98 and 568, that's 666. Add this row, 91 and 98, that's 189. Then add 225 and 568, that's 793. And that total should be 982 going in this column and in this row. Okay, so now we want the probability that the pedestrian was intoxicated, and I'm abbreviating PI for pedestrian intoxicated, or driver intoxicated. Again, DI represents driver intoxicated. Okay, now driver intoxicated is this row, pedestrian intoxicated is this column here. There is a gap, there is an overlap in these two. So here, that intersection of this row and this column is going to be this number, which is 91. So we do have to use the formal addition rule, which is going to be this. That's going to be the probability of the pedestrian intoxicated plus the probability that the driver was intoxicated, but then we have to subtract off the probability that the pedestrian intoxicated and the driver intoxicated. So we have to use that formal addition rule where you have the probability of A or B. That's going to be equal to the probability of event A plus the probability of event B. Then you have to subtract off the probability of event A and B. Okay? So we have to use that formal addition rule. Now, in the other example, we didn't because there was no overlap with the positive test result and the negative test result in that last example that I just did. But here there is an overlap. So in this case here, the probability that the pedestrian was intoxicated, that's this number, 316 over 982. That's the grand total. Plus the probability that the driver was intoxicated. So here, driver intoxicated, that total is 189 over 982. Then we have to subtract off the overlap of the driver intoxicated and the pedestrian intoxicated. That intersection is this number right here, 91. So it'll be 91 over 982. Now if you subtract, if you add 316 to 189 minus 91, you're going to get 414. And then your common denominator, that's your 982. So you have 414 over 982. And if you divide 414 by 982, you're going to get this number, 0.422. And when you do this on the calculator, you have to enter the 414 first and then divide it by 982, because your probability has to be a value between 0 and 1. So 0.422 represents the probability that a randomly selected pedestrian death was where the pedestrian was intoxicated or the driver was intoxicated. Okay. Alright, here's another example. In fact, I got a couple of more in this video that I'm going to do. Alright, in this case here, the table summarizes results from a study of people who refused to answer survey questions. A pharmaceutical company is interested in opinions of the elderly. What is the probability that the selected subject is someone 60 and over who responded? Okay, so now let's add these columns and rows together. 70 and 14, that's 84. 252 and 23 will be 275. 242 and 36 will be 278. 133 and 29 will be 173. 135 and 135 and 38 is 173. And 199 and 60 will be 259. And if you add these rows up here for responded, that total should be 1231. And for those who not responded or refused to respond, that total will be 200. And the grand total should be 1431. I'm sorry, 1231. And I think I told you 1,231. This should be 1,031 up here. So this is 1,031. And this will be 1,231 for the total, for the grand total. Okay. So if you add these numbers going across, it should be 1,031. And then that second row for refuse, this total should be 200. And then you should get 1,231 as the grand total. Alright, so now we want the probability of a person that's over 60 who responded. Now here we don't need to use a formal addition rule here, because if you look at this column of 60 and over and then responded, that number is 199 out of the total of 1231. So we can say this is 199 over 1231. And then use the calculator to do 199 divided by 1231. You'll get 0.162. So the probability of randomly selecting a subject who is over 60 and over who responded would be 0.162. And then the last example on this video would be this. Here you're going to use the following results from a test for marijuana use, which is provided by a certain drug testing company. Among 147 subjects with positive test results, there are 20 false positive results. Among 157 negative results, there are 2 false negative results. If one of the test subjects is randomly selected, find the probability that the subject tested negative or did not use marijuana. Okay, so let's construct the table. Okay, in this case here, I'm going to say use marijuana. And then I'm going to put yes or no. And then on the left side will be positive test. And then negative test. So you first have to create a table. And I'll put a total row, well, a total column here, and a total row down here. Now, it says among 147 subjects with positive test results, so the total number of positive test results will be 147. There are 20 false positive results. In other words, they did not use marijuana, but their test came back positive. So here, this would go under the no box and under positive test. Okay? False positive means that they did not use marijuana, but their test came back positive. So in this case here, for yes, we subtract 20 from 147, you're going to get the 127. Okay? Now, among 157 negative results, so under negative test, we have 157 here. There are 2 false negative results. Now, what do we mean by false negative results? Now, you want to be very careful where you put the 2 at. 2 false negative results means that the test came back negative, but they used marijuana. Okay? That's what that means. False negative means that they used the marijuana, but their test came back negative. So the 2 goes here. And to find out the number of people that did not use marijuana and got a negative test result, well, they didn't use marijuana and the test came back negative, so that would be a true negative result. Subtract 2 from the 157, you're going to get 155. Now let's get our total columns here. 127 and 2 will be 129. 20 and 155 will be 175. And the grand total will be 304. Either add 125 and 175 together, or 147 and 157 together, and you'll get the total of 304. Okay, so what we need to find is the probability that the subject had a negative test result, or I'm going to say not used marijuana. Okay, so here negative test is this row, not used marijuana is this column, so there is an overlap in those 2 events. So we have to use the formal addition rule that we talked about. So in this case, it'll be the probability of a negative test plus the probability that the person did not use marijuana minus the probability of a negative test and not use marijuana. Alright, so in this case, the probability that somebody got a negative test result, that's the total of negative tests, that's 157 out of 304. Plus the probability that this person did not use marijuana, that's this column here, that total is 175 out of 304, minus the intersection of a negative test and someone who not used marijuana. The number that's in the intersection of those 2 is 155 out of 304. Okay. So now if we take the sum of 157 and 175 and subtract 155 from it, you're going to get 177 out of 304. And as a decimal, 177 divided by 304 will be 0.582. So in this case here, the probability of a randomly selected test subject who tested negative or did not use marijuana would be 0.582. Okay, so this is how we apply the formal addition rule to these types of real-life problems. And that will complete this particular video on the addition rule.